So this is the first talk of Room 5. It's going to be Measure What Matters with Jetpack Benchmark by JB Lorenzo. Can I have a round of applause? Thank you.
Hi everyone, good morning. Thanks for being here. So my name is JB, and I'm going to talk about benchmarking in the apps. I work at a company called OLX. If you're not familiar with OLX, we are similar to Gumtree if you're in London or UK, or similar to eBay or Craigslist. So basically a marketplace for selling and buying things. And of course, if you have an app, you check the reviews. So one of these days, I was reading through the reviews and I found something like this. So lags, this is from our Ukraine app. This is self-explanatory. Some of it was translated straight from Ukrainian, which is people being bored with the lags that we get. Some of it's like not properly translated, but I think it's still related to lags. So actually, I asked some Ukrainian speakers, and they said this is quite close to what the actual meaning is, but this is badly translated. So, but you get the point, this is lags. And we also get some reviews also from other countries, such as Romania. This also lags, and this is a pretty detailed review coming from a person, looks like a developer, actually, because the person is telling that if you open the app, there's a lot of lags, and all the time it's saying connection error, and the ads kill the application. I think he's saying that some of the content that we have is actually slowing it down. So it looks like he's debugging our app for us, like free debugging for us, it's good. And this is also another one which is also related to lags. So it's saying that when you scroll, the app is very laggy, which is of course not a review that you would want to receive from your users. So these things actually made us want to start benchmarking our apps. And it's luckily that Google has released their new library called Jetpack Benchmark, which is what we're going to talk about today. Oh, yeah, there's another one, which is, I don't know if it was badly translated or if it was literal. The person saying it moves from infection to very infective. I don't know what that means, but that's just translation from Google. So Jetpack Benchmark, the latest release was actually from October 9, or right, hold on, they released something yesterday, which was RC1. And I was just scrambling to see what changed yesterday because it was night. I just came from my flight. There was a fire at the airport. Yeah, there's a lot of things going on yesterday. So probably some of the stuff that I'm going to talk about today will have some bugs or probably not work with this latest one. So just probably use the old one that I used. So the latest one that they have is from yesterday, which is the release candidate. It moved from Alpha 1, the initial release on May 7th. That was Google I/O. And as you can see, it's very fast. It's 5 months, and now they're on release candidate. So this is quite stable now. And what actually changed from Alpha 6 to Beta 1 to RC1 was some of these things, which might be a bit hard to understand for beginners, but I'll just go through it. So one is that they run garbage collection to avoid leaks. So when you run benchmarks, they run it over and over, more than 10 times. It's an undeterminate amount of time, but just the right amount of time to run it to stabilize the metrics. So it runs it multiple times, measures things, and then it sees if the difference between the measurements that it's getting is reduced to some level, so some variance, and then it stops after it reaches a stable value. And then another change was they added lint dependency, and then they added a parameter to correctly use this additional test output there. Because, of course, if you run benchmarks, you would need the output that it's giving you, right, the values. So this allows you to read the file afterwards. And then they just fixed the output to show if they were not able to detect your clock frequency for your phone, it's just returning -1. It's just bug fixes. And of course, I used it since Alpha 2. There's also some changes from Alpha 2 to Alpha 6. One is that it auto-disables test coverage. One thing you want to know is when you're running benchmarks, you don't want to run all of the other stuff that you have, like test coverage, which will make your benchmarks unstable. Unstable meaning the value that you get, the value that you're measuring will change from time to time. You want this value to be very stable so you can use this value as a reference or within a certain amount, within a certain range of values. And then it's using the benchmark runner by default. If you don't know, benchmark uses tests to run. So if you are executing your test, you need a runner. And Android benchmark runner, what it does is it adds checks to your test so that it detects if you're running on debug. You don't want to run benchmarking on debug because the values will again be unstable. And also you don't want it to run on an emulator because it doesn't show you the real performance of the code that you're testing. Another thing is that the module structure changed because they are preparing to move away from JUnit 4 into like a general testing framework. And then they changed the package name, which is like, yeah, because this is alpha, the interface will change. So you will have to be careful to update when you update it from version to version because this will break. And finally, they had documentation for CI, which is in this link. So another thing, aside from setting up the benchmark that we're going to talk about today, is setting it up on CI. So you want the benchmarks to run every time or regularly, not every time because some of your tests might take hours to run. What you want is to have a value that you can reference and then check if there are regressions to this value. So that's why you want it to run on CI. And what the documentation contains is if you want to run benchmark without Gradle, for example, if you're using CI, you just upload the APK with the test and the test runner. And of course, you don't have Gradle there. And you need a way to run the benchmark without Gradle. So this is documented there. And there's two ways to do benchmarking. One is self-instrumented APKs, which is just one APK containing the tests and also the code that you are testing. Another way is what I've mentioned, which is two APKs, which is one is the main app that you are testing, and the other APK contains the tests. And yeah, some guidelines for CI that they've outlined to, for example, the important flags that you want to toggle. One is to lock the clocks. If you are using a rooted device, it's dangerous to run the benchmark because if you've unlocked your clocks on your phone, it will run faster sometimes, and it will not give you a stable measurement. So you want to lock the clocks if you have a rooted device. But I don't know who has a rooted device for benchmarking. So this is just to check if everything is stable. And then the JSON output, which is very important. This is where the value that you would reference is coming from. So this is actually the file that you want to get after you run your benchmark. So how do you set it up? Very simple. If you have Android Studio 3.6 beta, this is not beta anymore. You just set this property to true on the configuration file, and you will have a new template in the wizard. So it looks like this. When you create a new module, there will be a new option for a benchmark module. So another thing that you want to know with benchmark is it can only test code that is inside Android libraries, not the app itself. It's designed to run this. So if you have, for example, UI or code that you want to test, you want to separate it into a module, a library, and then afterwards you can run your benchmarks on it. So yeah, when you add your benchmark, just put your package name and then go through it, and it will automatically, as you can see here, it's still using Alpha 6. It will automatically add this dependency to your project, which is the benchmark itself. And then another important thing to keep the benchmarks stable is to set your application debuggable to false. This will prevent you from running your test in debuggable because this is, again, making your benchmarks unstable. And if you have somewhere a value that sets this to true, you have to override it. So this is the tools replace attribute in this XML in your Android manifest file will override that value to false. And then also it wants you to ignore the hard-coded debug mode, which is when you run on Android Studio, there's a debug button, and you click it, it will hard-code the debug mode. this will also prevent it from using that value. So let's measure. One example is from a project that my colleague has made. This is one particular test there, which looks very simple. What you have is a benchmark, reference to the benchmark. You run it repeatedly. So this measure repeated is the core of this library. It runs this, the codes inside of this block repeatedly until it gets to a stable variation of values. And then it outputs a JSON with all of these values and also the average, which you can then parse later on. So here, what we wanted to do was to measure performance of our parsers, our JSON parsers. So here we have JSON under test, and then we are supplying it with sample values, one which is the smallest sample values that we have. And then we go through larger sets of JSON, and then we compare it. The problem that we were having is we had several JSON parsers in our app, and it's making our app larger than it should be. So in order to decide for us which one to drop, which one to keep, we started measuring. And yeah, at the end, we were able to come up with a conclusion. I'm not going to spoil it. I'll just go to the slides. And so now you're probably thinking, you're only testing logic. Can you test UI? Yes. So this is example of measuring the UI, which is quite complicated, but I'll go through it line by line. Don't worry. So this is a UI test. It's tagged by @test because it's run by the JUnit tester. So if you haven't seen UI tests, it has this attribute @test, and then you have to launch your activity somehow. Here we're using the activity rule. You can form it using the test recorder in Espresso, which will automatically form the test for you, or you can write it by hand. This is written by hand. And the other attribute that we are using here is UI thread test. So this will allow my test to modify to call UI code from this test. So I'm scrolling it, right? So usually the tests run on a separate thread. So if you run scroll on the recycler on a non-UI thread, this will crash. So this is why we're using the UI thread test. So the first lines is actually just setting up the activity that we are testing. This activity is the home screen of our app. And we are getting the recycler view. So the recycler view is inside the fragment that we have. So we're just finding a way to get it from the activity. And then we are measuring the scroll performance of the home screen that we have. So the home screen is not that simple. It has ads, it has images, it has the prices, and it has different sizes for each ad based on the height of the image. You'll see it later on. There's a video later showing what's happening. But here, what we wanted to do was to prevent the comments that we get from the reviews. So the reviews were saying that the app is lagging when you scroll. So what we wanted was to keep the scrolling performance stable. And in order to do that, then you would have to have a baseline measurement and then check if your changes affect this baseline measurement, then we have to dig deeper. That's how you do it in theory, but in practice it's a bit harder because sometimes the measurements is not stable. So I'll discuss that later. So going back to the work that my colleague has done, which is sitting somewhere here in this room. I'm not going to point to him. He's shy. So when you run the test, this is using command line, which is just running the APK. So it's not using Gradle at all. It's running in ADB. I'm not sure if you can read it properly. I hope you can. So it's running the set of tests that we've defined. And then, as you can see, we have 12 benchmarks here with 4 JSON parsers that we are comparing and 3 sets of JSONs. So 1, 2, 3 is getting bigger and bigger, the JSON size, and getting more complex. And if you probably cannot see, these are the averages from the benchmark. And from these, we based our decision to find out which one we want to keep. This is quite hard to read, so there's a graph that shows this. So those are the 4 JSON parsers that we were comparing for our code. And if you can see, the fastest one was Jackson. But unfortunately, Jackson was the biggest one in the bunch, which is like 1 megabyte for our app. And then the slowest one was Moshi. But this is Moshi with code generation, without code generation, which is quite slow. And then based on this, the second fastest JSON parser that we found was Kotlin serialization, which is not that big in library size. It was a few kilobytes, like 80 kilobytes. So we decided to keep that, and to keep deprecating the rest of our JSON parsers. So that's pretty much what we use benchmark for right now, and then we move to the UI benchmarking. So probably one of the questions that you have in mind now, if you're doing UI benchmarking, how do you run it in CI? You have a few options. One is to use Firebase Test Lab. One is to use Amazon EC2 plus the emulator. One is your own device farm. So the easiest things to set up here, if you can set it up, is the 2, which is the emulator and your own device farm. I'm saying this because the device is already directly connected to the CI that you're running. So you don't need a way to get the results from a remote device, extract it, and then parse it. So here, you can run the script directly on your CI, and then run the benchmarks and directly get the file. So I'm going to go through that first, and then I'm going to go through how to set it up in Firebase Test Lab later on. And there's one note that I should probably talk about, which is for using Amazon EC2 plus Android emulators, which is if you want to set your benchmarking in AWS, it does not allow nested VMs. So if you have, so emulator is a virtual machine, and Amazon instances are also virtual machines. It does not allow nested VMs. So there is a flag called KVM, which probably so much detail than you need, but this flag is not enabled on Amazon. So if you want to run Amazon EC2 plus the emulator, you can't. But they have bare metal instances, which is actual machines where you can run VMs. So, but that's much more expensive than the regular EC2 instances. And for the emulator, it's not advised to run benchmarks, of course, because it's not representative of the actual device performance. So this is probably not a good idea to run, but it's one of the easiest things to set up. There are other cloud providers that allow you to run nested VMs. For example, Google. Oh, I didn't list it. So that one, actually you can run the emulator, but again, the benchmarks will not be stable because it's running on the emulator. So how do you integrate benchmarking in your CI? In our case, we used GitLab, which is hosted in our office, and then this is how you set it up. You put the plugin in your project, in the benchmark project. It's already there if you use the wizard. So there's a plugin, Android Benchmark. What it does is it collects the file for you, the JSON output of your benchmarks, and then puts it in a file in your directory. So what's happening is when you run the benchmarks, the output of the benchmarks is inside of the device or inside of the emulator. And then this plugin extracts this file from inside of the device and puts it in your build folder. And then you can parse it afterwards. And if the device or emulator is connected to your CI, it's very easy to run. So you just run benchmark, the name of your module, and then connected check, which is running the UI test. So this is quite easy. And if you manage to get this working, you will get JSON output similar to this. So this is the output of the benchmark. The first few lines is just describing the environment where you run it. Here, it's saying I've run it on an emulator running on SDK 28. And then these are the values that you get from the benchmark. The name is the test name plus the warnings that you get. So when I run this one, it gave me warnings that I'm running it on an emulator, so it added it on the name. And I'm running the emulator with clocks that are unlocked. It means the emulator is rooted, the one that I'm using, and yeah, the clocks is not stable. So this is not a stable value for that. And then you can also see the timings that it got on the bottom. So the time is in nanoseconds. There's individual values at the bottom. I just didn't list all of them. But there are median and the minimum and the maximum values are there. Also, the warnings that I've got is also on top, which is CPU clocked and sustained performance. These flags I will talk about in a few slides, which is here. So when you run benchmarks, it will give you warnings when you are not setting up the environment properly. And so I'll just go through all the warnings that it has so you can understand what's going on, what makes a stable benchmark. One is when you have unlocked the CPU clocks. So if you have a rooted device, again, it will lead to inconsistent results when you have the clocks unlocked. It's hard to say. When you have a rooted device, you should really lock the clock so that you have the measurements consistent. Let's find all the warnings. One of them, which is here, when you're running an emulator, as I've already said like 3 times, it's not representative of the device performance. So what you want to have is run it on an actual device and keep that device as the reference. You don't want to be comparing devices. You want to compare your code on the same device and run it over and over there and use it for regression later, or see if you can improve the performance later on. And then there's also a warning about sustained performance, which is a temporary screen that prevents your phone from sleeping and prevents your phone from going into the low performance mode. So what they did was they are launching the screen on your benchmark. You'll see it on the video later. And it's preventing your phone from entering this low performance mode. So what you want is to measure the benchmarks on the highest performance on your phone that you have. And yeah, there's like a fix for this, which is to use the runner, which is actually already doing this for you. And also when you have low battery on your device, it will lead to your device going into this low performance state, and you don't want this to happen. So this will give you a warning when you run it on your CI, for example, and your device is running out of battery, and that it will not run at all, and you just need to wait for it to charge. Another one is, I've already mentioned, debuggable. You don't want to run your benchmarks on debug builds because it has a lot of things that are not there on the actual production app, and you don't want to measure those. You only want to measure the one in your production app. And this one is specifically for if you're not using the runner, separate to the other one, similar, that is also giving you warnings when you don't have the runner. And this is not probably relevant anymore because it's already disabling code coverage by default in the newer versions. And this, I just found it on their code. This is saying like if you are using engineering build on your device, don't run the benchmarks there because it has a lot of customizations and you don't want to measure or use this as a reference. So aside from Amazon EC2 and the device farm, you can also set up your benchmarks on Firebase Test Lab, which is quite easier to set up than using your than launching your own device farm or asking someone to set you up emulators in EC2 or other cloud servers. So if you want to run your benchmarks on Firebase Test Lab, what you have to do is mock everything. So again, if you're running UI test with real network, there's probably something wrong that will go there, something wrong that will go on there later on. So you don't want to do this to happen, so you mock everything. Mock the network, mock the file. I've also talked to another speaker, which is also talking about benchmark. They're also mocking the actual file system, but this is too much for us, so we just mock the network for now. Another thing is it's not free. After the free tier, you have to pay, but probably not as much as if you set up AWS. I don't know, I haven't compared the prices, but this doesn't look so much. And then you need to configure Google Cloud in CI. So the Firebase Test Lab, what it's doing is it's running on actual devices, right? You can select actual devices, and then the output of the things that you run there, you can extract by using Google Cloud. So the storage that it's using, Google Cloud, you can extract all the files that you have produced afterwards. And then for the CI to be able to access that, you have to give it the key, so it can extract it later. Yeah, that's what I said. And then one quirk in benchmarking that we discovered is when you are running it in Firebase Test Lab, there's no way to get the file unless you override this flag, which is Android X benchmark output enable true, which is outputting the JSON. This was from Alpha 6, so I'm not sure how's the case now with the release candidate. The problem was, if you're running Gradle, this flag will be set to true, which is very handy. But if you forward your test to Firebase Test Lab, it's not running Gradle. And I've tried supplying this flag by passing it on the curl command that you're using, similar to a curl command when you're running Firebase Test Lab. It doesn't accept this parameter. So the only way that we found to enable the JSON output when you're running it on a remote device is to override the application and supply the argument manually. So on onCreate of your application, you supply this value on the bundle, and then later on, the plugin can, or benchmark library can read this value and actually say, okay, you want the JSON output, then I will produce it for you. And then you can extract it later. So let's see how you parse the output after you've got the JSON output. But first, this is how our GitLab CI looks like. So here we have the benchmark job. I'm not going to go through all the lines. It's just setting up, unlocking the credentials to be able to build the project. And then we run connected check on benchmark. This was when we have emulators running on the CI. But if you have Firebase, this would look differently. It would be the Firebase Test Lab commands to upload the APK, and then to call gcloud later and extract the files from gcloud. But after you get the file, you run a script, for example, this one, which is parsing it with Python and loading all the benchmarks array that you've seen earlier, and then getting all the medians, which is similar to an average, but in the middle. And then afterwards, you can use this median as a reference value for each of your build. So when you run it in CI, what you want is, when you get the value, you compare it with an old value that you have. And then if it's within a certain range, then you accept it. Otherwise, you fail the build, and then ask people to look deeper into it, what happened. And actually, there's a more advanced version of this by Facebook, which is also going to be talked about by a guy here in the conference on the second day, which is what they do is they find which commit is actually made the change in the benchmark. So they do like a binary search for each commit, and then tell the developers, okay, in this commit, this is where you introduce the regression in your benchmarks. So that's pretty handy, but that's too complex for our CI right now. But yeah, that's one of the best ways that you can do it. So this is an actual value that I've got from one of the tests. So if you have a previous benchmark, you can probably commit this value on your CI. This is the simplest approach, by the way. And set a threshold, and then, okay, the code actually is wrong here. Threshold should be 1.1, not 0.1. So when you have the value, you compare it to a threshold. So if it's above a certain range, so if it's above 10%, means like 10% slower than your previous run, then you reject the build, and you failed it. And then the developers will now have the alert to say, okay, something went wrong, we have to check it and see what made our app slower. So this will prevent the regressions that you have and prevent further lags. But if you already have lags, then you have a different problem. So this is an example of the run. If you run it manually on Android Studio, this is how it looks like. I can also actually show you it running. but I didn't pray to the demo gods. So let's see what will happen. This is my device on the right. And I will just run all the benchmarks, the UI benchmarks at least. Oh, not debug. Run. Takes a few seconds, so I'll just go back to the slides while it's being run. So what we're doing here is we're testing scrolling. First is linearly scrolling through the list, just going down all the way to the list. The second one is random scrolling, up and down, based on a random number generator. And then the last test here was clicking ads. So as you can see, this is a very simple suite of tests just for the home screen to prevent lags. And then if you have errors that you can suppress it. For example, if you really want to debug your test while running the benchmark, you can do it by suppressing the errors here and providing it as an argument in Gradle. And this is very useful. For example, when I first set up benchmark, I got a lot of errors because our app was not made to be UI tested in this way. So I encountered several issues that I have to manually supply values into our application because I shut off the network and yeah, it's not running at all. So I had to mock everything. And in order for me to do that, I had to set debugging to false, and this helped me a lot. Well, this is the test running on TestLab. The first one is just linearly scrolling. The second one is randomly scrolling up and down, depending on the random number that it generated. And the third one is opening the ad. If you can see, there's like a temporary screen appearing, which is Android benchmark runner. That screen is actually preventing your phone from going to low performance mode. And it's making sure that the test is running on the highest performance that it can get on your phone. And yeah, this is quite handy because one, the Firebase Test Lab also provides you with videos, which is this one. So you can see if something went wrong, then you can immediately see here. And another thing that you will notice here is that it's not scrolling very smoothly. Because the test is running very fast, it doesn't draw, the drawing doesn't catch up with the actual scrolling. But we're not testing how smooth the UI is. We're testing here how fast or how long it takes to scroll one item. So we can set it as a benchmark. Actually, one of the questions that I got before while I was presenting this one was, what are we measuring here? Are we measuring frames per second or like the inverse of frames per second? I would say it's similar to that. But what you're measuring here is how long it takes for your task to be done. So it's similar to the inverse of frames per second, but actually only that part that you did. So in this case, it's scrolling one item, and the other one like randomly scrolling, and the last one is clicking on an ad. And let's see if the test is finished. No. I had to allow location. Okay, let's just go back to that. Okay, yeah, the demo guys doesn't like me. Let's just try it again and go back to the slides. Oh, it's working. Yeah, it's very fast. As you can see, it just went through the first test very fast. And then the second one should be randomly scrolling, but the drawing doesn't handle it for some reason. I've also checked if this was a bug in our benchmark. It's not, because I've run examples made by Google. They have examples of scrolling recycler views with sample values, and it's also doing the same thing. It doesn't show scrolling smoothly. It's just flickering very fast. So this is actually right. So here you can see the values that we've got. The first one, linearly scrolling, is 2,000 nanoseconds, which is nothing. The second one, randomly scrolling, which is a bit slower. And the last one is the slowest one, which is opening an ad. So with these values, we can set these as reference and then monitor the performance of the app regularly. I wouldn't advise it on every commit or on every merge request. It would be too much if you have a lot of tests. And then you can perform what Facebook does, which is binary searching which commit made this change in the performance. But yeah, that depends on you, how you set it up. So let's go back to the slides. So if you want to start this now, then you first have to separate your app into modules. As I've mentioned, the benchmark doesn't allow you to test code which is inside of your app. So you have to separate, for example, your UI, put it in library, and then you can test it afterwards. And the next thing you want to do is mock all the data that you are using for benchmarking. You don't want network to affect your benchmark. You don't want, for example, files to affect your benchmark, or a lot of things like values or A/B test flags that you have. So mock everything that you have, so you can run a stable UI test. And then, yes, try it out yourself. Oh. And yes, visit the issue tracker. It's quite stable now, but as I've encountered issues before, it was very helpful to look at the issue tracker if there's a similar issue, because this thing is not in Stack Overflow, as I've seen, and file bugs. And if you want to try an already existing project made by my colleague here, you can go to this GitHub link. There's no code from our company here, so it's safe to release, I hope. And you can check it out, run the benchmark. It's still using an old version. I think I might have time this weekend to update this, but basically now you can try benchmark here. If you don't want to add it to your own project yet, just run this one for now and see if it fits your project, and then check out. If you already have UI test, this will be really good. You can just put the UI test, wrap it around, measure repeatedly, and then you can get values afterwards. The issue tracker is here. Some of the talks that are related to this one that you might want to check out is this one from Google I/O by the original authors of the library, which is improving app performance with benchmarking. Here they discuss how they built the benchmarking library from the internals of it, and then why they're doing certain things, like why are they not allowing you to run it on an emulator, why there's this screen which is showing up preventing your phone to go into low performance mode, and why they don't want you to run it on low battery, all of these stuff. And they actually released a new Medium article about the library. This is how they use it inside of Google. So this is a very weird graph, very, I don't know, it's like an abstract painting, but this is actually the benchmarks that they are running. They have several different tests and several different runs of the benchmark. And what they are trying to do is figuring out the best way to see if there was a regression or not. Because an increase or a slowdown in running of the benchmark doesn't mean that there was a regression. It just means that there might be some variance that affected it, or some condition that we did not account for before. So what they are discussing is what is the best way to find if there was a regression using this series of data that you have. I'm not going to detail into that, so you just check out this Medium article that they have. And I think this is the map of our company. So this is where OLX is, or the parent company, Naspers. It's everywhere except London, I guess, and Australia. So I don't know why I'm here. So these are the brands that we have. Probably some of these are familiar if you don't come from here, or if you come from a poor country. All of these are familiar. And these are our offices. We have an office in Berlin. I'm currently based there. My colleague as well. And yeah, just reach out to us if you're interested. Not sure if there's any current open positions, but we are always considering good talent. Yeah, that's it. Thank you. Yeah.
All right, we have some time for questions, if someone has a question. Yeah.
Yeah.
Sorry.
Get the mic.
Hey, in one of your slides, you had a previous benchmark number.
Yeah.
Do you run that every time, or how do you decide when to rerun that number again? And
So
also, how do you store that so that the next CI run has access to it?
currently, it's inside of the repo. So you just use the same device that you've generated it from, get the value, put it in the repo, and then you use it for the next runs. So you need a way to have that value initially, but you need to keep running that benchmark on the same device or set of devices. Yeah.
All right, any more questions?
Yeah. There.
Thanks for the talk.
Yeah.